Okay, the last thing that we're going to talk about in Chapter 4 is solving equations with powers. Both integers, which are kind of like polynomials, which we've done before. We're going to do single value polynomials. And then we're going to involve rational and negative numbers. Alright, we'll be using algebra methods, and then we'll kind of check them graphically. It's always a good idea, because graphs kind of help you out, especially if you're struggling with solving these algebraically. You can always revert. You have your graphing calculator. You can always use it in this class. All right, the first few examples, though, I won't. I'm just going to go over. So the first few, we're going to do some examples. We'll do some simple cases. And then we'll get into the harder cases, and I will go over the graphing method. All right, so first, some simple examples. So we'll start off with just the integer cases, where it's just a single integer value we want to solve for, but there is stuff you have to watch out for. Alright, for instance, if I want to find what x squared equal to 16, so you've got to remember when I'm solving this, and so using sort of the new rules, it is the square root property. So if we use the old rules were the square root property, right? I found x, it was plus or minus the square root of 16, x equals 4 and negative 4. And so I've got to keep in mind this. Whenever I solve even powers, and I use even power roots or fractions, all right, we always have to find the plus minus. There are always two possible solutions. All right, then you should always check, because sometimes, remember I told you whenever we're dealing with roots, you should always check, and sometimes we have to throw stuff out because it doesn't check, so you should always check yours. And so kind of using this idea with our roots. And so I'm going to solve the same thing using sort of the root method. So x to the 1/2, or x squared, is 16, and what we're going to do is, well, I want to get rid of the square. Well, I'm going to raise it to the 1/2 power. Whatever I do to one side of my equation, I have to do the other. But I have to remember I'm using an even powered fraction, and so there's a plus minus out front, only for the even powered cases. And so again, those cancel each other out, leave me with x. I have the plus minus, that is the square root of 16, and so I get the same answer. And so again, it's the same idea whenever we're dealing with even powered roots. So I've got to keep that in mind. So when I want to solve for the following, x raised to the 4th equals 1 over 81. Alright, well, you could take the root of it, but again, like I said, we don't usually do roots in these cases. We want to use the fractional powers. And so I'm going to raise this to the 1/4 power, and I'm going to raise this side to the 1/4 power. Keeping in mind, because I use the 1/4 power as an even root, even fraction, it's a plus minus. I've got to remember this plus or minus. And that's easy to forget. It's easy for me to forget. Sometimes I do. Alright, so this cancels each other out, leaves me with just x. Here I've got the plus minus, and I'm going to rewrite, remember, I can rewrite 1 over 81 as 81 to the negative first 1 over 4. Or again, you could type it in the calculator, but sometimes it's just easier to type it in as right, I can multiply those out, so that's negative 1/4. Alright, again, it's up to you. It doesn't really matter. You can do whatever, again, you want. It comes out, if you use your calculator, it comes out 0.333333, which you have to remember is 1/3. So it's plus or minus 1/3. So x is equal 1/3, or x is equal negative 1/3. You should check it. It does check. If you take 1/3 raised to the 4th, you get 1 over 81. If you take negative 1/3, raise it to the 4th, you get 1 over 181. Or you get the fraction of it, but you remember you can hit your fraction key, and it will solve for that. So again, you can always check. This is sort of my check step, so that's the right answer. Right, the same thing's true with odd-powered roots. So if I want to solve for x cubed equals 8. All right, now that one you could probably do in your head. All right, but if I want to solve that using the root property, I raise it to the 1/3, I raise it to the 1/3. It's odd, so you don't do plus or minus, it's odd. And so those cancel out, leave me with x. I've got 8 raised to the 1/3, which I can type into my calculator, and I get one answer. There's one place where that happens. All right, x equals 2. Okay, so those are some simple power function rules. Another example of that would suppose I have x to the 5th equals 1/625. And so same thing, it's an odd root, so I can raise this to the 1/5 power, raise this side to the 1/5 power. X equals whatever, 165 raised to 1 over. So I know it's going to be a fraction, right? Because I get a negative. 1/625 raised to the 1/5. And I'm just going to type that out of my calculator and then hit my fraction key. Which actually this one doesn't come out to a nice fraction, so it's just approximately 0.2759 if I round 4 decimals. So that one doesn't come out real nice and pretty. So it's exactly the 5th root of 265. Or the decimal approximate 0.2759. Alright, so those are some simple cases. And the next, so that's my first video, and getting you used to remembering this rule. And you have to keep this in mind even for the next one. If you have even powers, even powered roots, so if I take the 1/2 power, the 1/4 power, the 1/6 power, right, even powered roots, I have to tack on this plus minus just like we did with the square root function. Odd powers, I don't have to do that, and you should always check your answers because sometimes answers don't check. And so those are the simple cases. So in the next videos, I'm going to go in the more complex cases. The more complex cases are first going to be cases where I've got fractional powers, and then we'll do the more complex where I've got more than one power functions adding or subtracting together. In those cases, we will check our answers graphically. Alright, I'm going to stop there, and I'll do the next examples in the next video.